Hi learners, I am Dr. Ramesh Babu, Professor of Practice from SR University, Warangal, India. I welcome you for this session on facility layout decision in operations management. This is the part of lecture series on operations management. In this session, we will learn about how facilities are designed, how layouts are selected for various scales of production. In manufacturing, an entrepreneur need to plan about the layout much in advance before constructing a facility. There's a planning stage. If an entrepreneur like to manufacture various varieties and variants of the product in large quantity, they need to set up a mass production facility so that efficiently operations are done. Now let us see in this picture image, machines are arranged on the floor in a row. Another set of machines are arranged in a row. There's an aisle space on the floor marked with yellow line for movement of material handling equipment like forklifts, movement of materials, and people. And all the support services are built around this. So this is called a layout of the shop floor for manufacturing, where machines are arranged, materials are moved, raw materials are moved based on the production process, and manpower is allocated, and there is movement of work in process materials, inventory raw materials, semi-finished materials in an orderly manner, so that work is not hampered anywhere and operations are done efficiently. This looks a moderately well-designed layout. And in this lecture series, we also will see various kinds of plant layouts suitable for job production, batch production, and mass production for various products. Now let's see the considerations for this facility layout decision. This facility or manufacturing or plant are used interchangeably. So a plant layout planning includes decisions regarding the physical allocation of the economic activity centers. This economic activity centers can be assembly lines, processing lines, various manufacturing activity centers. This also can be a warehouse, can be a distribution center. Proper layout facilitates easy and efficient movement of man and materials. So the objective of plant layout planning is a more effective facility. To facilitate allowing workers and equipment being more productive. So we say an economic activity center is any entity occupying space. So when it occupies space, that space has to be planned and utilized properly. Once a facility layout is fixed and machines are set up, it becomes very, very difficult and expensive to change the layout later. So various facility layout techniques apply to the case where several physical means have to be located in a certain area, either industrial processes or services. Take service like airline services, banking services, insurance office services. Even there, proper layout is required to allow for service to happen in the more efficient way, most efficient way. So in this lecture, we also will learn about plant layout and also re-layout in case layout decision need to be changed. And to carry out an appropriate plant layout, it's important to take into account the business strategic and tactical objectives. So this facility layout decision is a strategic decision. So to make a decision about layout planning, 4 different questions must be answered. First one is, which centers do we have to consider? These are the manufacturing centers. How much space and capacity is required for each center? If there is not enough space, productivity may affect. Too much space buying is also expensive and also can reduce productivity. Third question is how must the space be configured at each center? Space, quantity, shape, and the elements of the work center are related to each other in this case. Where should each center be located at within the facility? Within one facility, for example, a car manufacturing facility, if there are three model cars are made, there are three assembly lines, how they should be located and constructed. This allocation of different facilities also may affect the productivity. So even though we'll be discussing more about layout decision, let us also see a case of an existing facility where production is not happening efficiently, where a re-layout is required. So to do this, basically, three types of changes to be done for any existing facility. If there is a requirement for re-layout, that can be because of changes in the production volumes. If the company grows, turnover increases, the volumes increase, you need to relay out the facility to accommodate more production. Or sometimes it happens that there is a change in the process and technology. Again, a re-layout may be required. And when there is a change in the product itself characteristics, so re-layout is required. So the frequency of the re-layout will depend on the requirements of the process. We can see here an image which has got some machine, very difficult to identify. There are raw materials. On the left side, you can see there are tools in the cupboard, but this place is not properly designed. This itself indicator that the layout of the shop floor must be redone. So these are the symptoms to do a re-layout. Now let us see the basic facility layout definitions. So a facility layout is an arrangement of everything needed, every machine, center, assembly line, all that, everything needed for production of goods or delivery of services. A facility is an entity that facilitates the performance of any job. It may be a machine tool, a work center, a manufacturing cell, a machine shop, a department, a warehouse, etc. The layout design generally depends on the product's variety and the production volumes. These are the important criteria. How many varieties of products we want to make, and each product how much quantity. This is the basis for layout design. So broadly, four types of organization are referred to. That is fixed product layout, process layout, product layout, and cellular layout. Now let us see the objectives of this layout decision. The main objective consists of organizing equipment and working areas in the most efficient way, and at the same time satisfactory and safe for the personnel doing the work. So we need to keep in mind the efficiency and safety of the personnel also. Let us see the objectives. Sense of unity is the first objective. So the feeling of being a unit pursuing the same objective, the team feels it. So minimum movement of people that must be ensured. And minimum movement of materials and resources also is required. Any unnecessary movement is a wastage. Then safety in the movement of materials and personal workflow. Another objective is flexibility. So in designing the plant layout, taking into account the changes of short and medium terms in the production process of manufacturing plant. Whether existing layout is flexible for change or the new layout being planned is flexible for future changes must be kept in mind because technology is changing, customer wants and needs will change. So we should keep in mind this while designing the layout. And another objective is congestion reduction. So should avoid any kind of unnecessary congestion. Then elimination of unnecessary occupied areas. Then reduction of administrative and indirect work. Unnecessary work must be avoided. We all know wastages. Wastage in machine time, man time, energy, unnecessary transportation, all this that must be avoided by careful planning at the layout design stage. The layout should facilitate improvement on control and supervision, better adjustment to changing conditions, better utilization of the workforce, equipment, and services. That should reduce the material handling activities and stocking process. Now let us see various types of this facility layouts. The production process normally determines the type of plant layout to be applied to the facility. Let us see most common layouts. First one is product-oriented layout. This is also called product layout, line layout. Second one is process-oriented layout. This is also called functional layout. Third one is cellular layout. Fourth one, fixed position layout. So in the first one, the machinery and materials are placed following the product path. How the raw material will move accordingly, this layout is decided. This is called product layout. Second one is process or functional layout. Machinery is placed according to what they do and materials go to them. Means here we keep particular kind of machines in one room, one cell or one unit. Like all the lathe machines are kept in one room, all the milling machines in another room. In case of food processing, all frying equipment one room, all cutting equipment in another room, all packaging in another, like this. In cellular layout, we try to take the advantage of both the above layouts. It is called a hybrid layout. Then in fixed position layout, the product stays at a place. Product is fixed. All of the resources like machinery, tools, equipment, accessories, manpower will go to the product. For example, aircraft manufacturing. Aircraft raw materials cannot be moved on the machines to make the aircraft. Aircraft is built at a place, fixed. All the resources are brought to the product. Let us see a typical plant layout. On the left picture, you can see garment manufacturing. The machines are placed in a row. There are two rows of machines. On each machine, there is one person working. There are trolleys and trays available. Looks like a garment or textile factory. So where processes are happening in a line, there is yellow color lines for material movement and conveyor movement or people movement. On the right side, you can see a machine shop where fully automatic computerized control machines are placed. Then there is a person working on each machine. There is an order and a tidiness in this layout. You can see such layout will facilitate efficient operations and clean and neat work area. Now let us see the first kind of layout, that is called product layout. This kind of layout is useful when the production process is organized in a continuous or repetitive way. Continuous or repetitive way means this is used for simple products and large volumes, where we see a continuous flow. So the correct operations flow is reached through the layout design. Say it's not a manufacturing facility. So the first step is mix the ingredients of the chocolate, sugar, cocoa powder, milk powder, various ingredients. Then after mixing, desired proportion, it goes to next machine for heating and mixing. Third one, molding process to make the chocolate into desired shape. Maybe heating is there, then it goes to a cooling chamber where it is cooled. It goes to a packing machine for packing and labeling. So these five machines are in a row, operations are in a row. When you want to make large quantity of chocolates, so this product layout suits. So the correct operations flow is reached through the layout and design of the equipment and machinery specifications. And we can see in assembly lines and repetitive flow. Correct operation flow will be based on a line balancing exercise like a refrigerator manufacturing assembly line. So when a conveyor refrigerator is assembled for each component at the stage, it reaches the finished stage, the final thing. And the plant layout will be based in allocating a machine as close as possible to the next one in the line, in the correct sequence to manufacture the product. You can see in the diagram. On the right side, you can see a U-shaped production line, product layout, where Raw materials will enter at this place in. Arrow mark indicates transfer of raw material or local movement of raw material. Rectangular 1, 2, 3, 4 are the machines. Raw material will enter machine 1. For example, chocolate manufacturing. Ingredients will enter here. Ingredients are mixed in this the first machine. Then the mix will go to second machine where there is heating involved. Then second stage of mixing. Then the mixture will go to third stage. Third stage can be a molding machine where chocolate takes its shape. Then it will go to cooling process to set the mold. Then goes to next stage for quality check and packing, secondary packing, labeling, etc. So finish it go to the finishing stage as a final product. On the left side diagram, you can see raw material center from the left side of the diagram. There are two production lines here. Product A, the straight line, making 1 to 6. When it crosses 6, it becomes the finished product. Say a company want to make two kinds of chocolate. So chocolate variety one run on this first line, product A, and product B has got different characteristics of chocolate. So it has got more complex ingredients and processes. So it takes 1 to 6, then go to 7, then 12. After 18, the final product is ready. So the plant may have such assembly lines, production lines. These are called product layouts. The machines are arranged in a sequence. The sequence need not be straight line like 1 to 6. It can be U shape, S shape, M shape, or any shape. At every stage, raw material comes from the previous stage and it goes to the next stage, except the first and last stage. This is called product layout. So this layout facilitates for a large volume of production. So generally, this is suitable for mass production. Now let us see the advantages of the product. First one is reduced material handling activities. There are minimum material handling activities because after each machine process, it goes to the next machine. It feeds the immediate next machine. The WIP, the work in process, almost eliminated here. There is no stock after each machine. It is a continuous flow. And it takes minimum manufacturing time and simplification of the production planning and control systems. It is very easy to control such assembly lines or product manufacturing lines in the product line. And it allows for tasks simplification. However, there are certain limitations. First one is no flexibility in the production process. When you're making a chocolate, the machines are set to make that chocolate. So you cannot use it for a different configuration or composition. Low flexibility in the manufacturing times. So all should flow in the same set. So there is no flexibility. High capital investment, because here each machine is an expert machine, specialized machine. So we cannot immediately change to other product. We cannot change the high capacity machines because the investment is very, very high. You cannot replace the machine just like that. And they are exclusively meant for that particular activity. Next one is every workstation is critical to the process. So the lack of personnel or shutdown of a machine stops entire process. One machine breakdown, entire flow stops. Again, people working on this will feel that work is monotonous because they are not become expert on each machine. But however, each fellow is an expert in that particular machine. Now let us see another layout type that is called process layout. This is also called functional layout. This type of layout is useful when the production process is organized in batches. So this is useful for batch production. The personnel and equipment to perform the same function are allocated in the same area. The different items have to move from one area to another one according to the sequence of operations previously established. The variety of products to produce will lead to a diversity of flows through the facility. So the variations in the production volumes from one period to next one may lead to modifications in the manufactured quantities as well as the types of products to be produced. Here we can see a process layout or functional layout. The outer rectangles indicate one section or department or wing. The first one is a shearing section where shearing machines are there. Next is milling section, drilling section, and packing section. This is for engineering products. Say one component has to be manufactured. Say product A. Product A raw material goes to shearing machine, then it moves to milling machine, then it goes to again shearing machine, and A comes out as a product. Now let us take another product B. Raw material for B product is a different operation. Enter shearing machine, shearing is done, milling machine, milling is done, drilling machine, drilling is done, another drilling operation on another machine is done, then packing machine, another packing machine out. So based on the processes required on that product, the raw material need to move to different sections. However, this will allow for batch productions. Here we can see each group of machines. For example, all these triangles are one set. All rectangles another machine, all circles, all diamonds, all star shape. So like this, particular set of machines are kept in one room. So in this diagram, we can see three jobs are made. One will pass through the operations required as per the product operations. So here we can fabricate or manufacture as per the customer requirements in batches. Another kind of layout is called cellular layout. So cellular layout combines both the product and process layout aspects. Machines are grouped into cells based on the processing requirements of a family of similar parts or products. Each cell is designed to perform a specific set of operations, and products move through the cell in a sequential manner. The characteristics are machines are grouped into cells. Each cell is dedicated to a family of similar parts of products. It combines the advantages of product and process layouts. This helps in reduced material handling compared to process layout, improved production flow compared to process layout. The typical diagrams for different layouts. You can see here, based on the product types. See here, O-shaped product, another shaped product. So based on the operations required, this will move to different machines. However, on the right diagram, you can see this itself is a cell in a sequence. Another cell in a sequence. So this is called cellular layout. Based on the all T's are on the first one. M's here. So based on the requirement, you can use this layout based on the volume and kind of products. The advantage of cellular layout. It increases the flexibility compared to product layout. It reduces the material handling compared to process layout. It has got shorter production lead times compared to process layout. It improved production flow, reduced WIP inventory. However, it has got some limitations like it requires careful planning and analysis to identify part families. Duplication of some equipment may be necessary. You can see in the diagram, machines are idle at some places. This can happen. Can be more complex to implement than product and process layout. And the last kind of layout is fixed position layout. This is also called project layout. In a fixed position layout, the product remains in a fixed location, and workers, materials, and equipment are brought to the product. This layout is used when the product is too large or heavy to move. The characteristics are the product remains stationary, workers and equipment are moved to the product. It is suitable for large and complex products. High degree of customization is possible. As per the customer specifications, we can make it. But it takes long production lead times. How a future layout looks, we can see here. So on the left diagram, we can see there is a project site. Something has to be constructed. So all the supplies will reach there. All humans need to reach there. All the material resources need to be brought there. Energy as an input is required. All the logistics and supplies are required. So we bring all the tools, machinery, say for example, making of a ship. So all the tools, materials, manpower need to come there to set up, to build the ship. On the right hand, we can see an aircraft manufacturing facility. This is done in fixed position layout. Various components are brought to one place. There it is assembled. Engine is brought and assembled. Wings are brought and assembled. All the sensors, avionic, aviation, electronic components. So these are the human workers and equipment. All the welding machines need to be brought to the place of assembly. So generally fixed layout is suitable for making missiles, ships, aircrafts, railway equipment infrastructure, all heavy projects. Let us see the advantage of fixed layout. Fixed layout has got high degree of flexibility. For the customer requirements of specifications, we can modify which are not possible product layout or process layout. And these layouts are suitable for large and complex products. And it minimizes the movement of the products. Here, absolutely, there is no movement of product at all. In product layout, we move the raw material to each from one machine to another machine. However, there are disadvantages in this layout. First one is high material handling costs, because we need to move all the sub-assemblies and resources to the product. And the scheduling is very complex in this. In case of product layout, scheduling is very, very easy. Machines are grouted onto the floor and fixed in an order. Then it is very easy to schedule the production quantities. And even coordination is complex in this case. You can imagine the ship manufacturing. Lot of components. Aircraft assembly. Nearly 25 lakh components or 2.5 million components are assembled in one aircraft. So this fixed layout case, it requires skilled labor. One should be expert in various tasks. And limited space at the work site is another issue. Now let us see what are the factors influencing plant layout design. Several factors influence the selection and design of a plant layout. That includes, first one is product characteristics. To decide what layout we want to go for, first we must have clarity on what are the type of product, size of the product, the weight and density of the product, and complexity features of the product. This is the first criteria and most important. Second one important criteria is production volume. How much quantity we want to produce, how much we are going to sell, how much quantity we are going to produce. These two majorly decide the layout. If the production quantity is high, more than 1 million, and the varieties to be made are one or two, product layout is the best layout, which allows for mass production. When we want to make, say, in the order of more than 2 varieties, to 5, 10, 20 varieties of like shoes, laptops, mobile phones, and the quantities are in the order of thousands, few thousands, okay? 1,000, 10,000, 20,000, 90,000. This order, then batch production kind of facility like process layout suits. If we want to make only 1 or 2 numbers, then it is a project production. Fixed layout suits. And sometimes when you make batch productions in large quantity, cellular layout will suit. Let us see the other factor, which is process requirements. The sequence of operations and the type of equipment required. This has to be seen. What is the sequence of operations to be done on that new product or product, and what type of equipment are required. Another factor is material handling. What we are going to do with the movement of the materials. Are we going to set up conveyors, automatic systems, or manual movement? So the methods and equipment used to move the materials, this also affects. Then space availability. How much space is available for our new factory to be set up, new plant to be set up. So the size and shape of the building also matters. Then safety considerations, because it has to be ensured a safe working environment. The layout should facilitate automatically for safety of the people and machinery and processes. Flexibility. So the ability to adapt to changes in product design or production. Today we are making some X design product. Maybe after 1 or 2 years, the market requirements may change. Maybe we need to incorporate better design features in our product. In that time, the processes may change. We need to modify our layout. So first, layout design should facilitate for future changes, re-layouts. And the cost, what are the initial investment and operating costs need to be known to decide the plant layout design. Now let me summarize this session. Choosing the right plant layout is critical for optimizing production efficiency and minimizing the costs. So each type of layout has its own advantages and disadvantages. And the best choice depends on the specific characteristics of the product, production process, and the overall business objectives. So by carefully considering the factors influencing plant layout design, manufacturers can create a layout that supports their operational goals and enhance their competitiveness. So for any businesses to start, one need to decide how many varieties to be made. Here variety means variants, models. The shoe manufacturer need to definitely accommodate the various sizes of the shoe and designs, color combinations. And definitely in batches they need to make. A shoe company cannot make one model, one size and sustain in the market. Customer requirements will be different for different shoe size requirements by age. Similarly, food manufacturing, fruit juice manufacturing, car manufacturing. So all these require proper space layout design. So we should consider quantity and variants. Based on that, we decide mass production, batch production, or job production. So based on that, we decide product layout, process layout, cellular layout, or fixed layout. Because layout design is an expensive affair. Once it is done, being re-layout becomes unnecessary expenses for the company. So one should carefully design the layout and install the machinery for efficient manufacturing operations. So with this, I'll be closing this session here. Thank you so much. Have a good day.